Hello students, in today's class we'll try to take up one result. Let's get started. The question is if vector r is equals to xi plus yj plus zk and r is equals to modulus of vector r, prove that del r power of n is equals to n r power of n minus of 2 into vector r. What is given over here? It is given that vector r is equals to xi plus yj plus zk. Now let's try to find out modulus of this vector r. Suppose if I take the modulus of this vector r, modulus of vector r will be equals to. Now since xi plus yj plus zk is a vector, then the modulus will be the square root of, you have to take the coefficient of I is x, so x square plus coefficient of j is y, so y square plus coefficient of k is z, so z square. Therefore, we got modulus of vector r. But if we try to observe over here, modulus of vector r in the question is given as r. Therefore, we can take this value r is equals to, it is square root of x square plus y square plus z square. That's the value of r we have got. Now, once you got the value of r, let us go ahead and try to prove this result. Now, to prove this result, you should know this del value. What exactly is this del? So, let me write down the value of this del. So, del is nothing but dou by dou x of I plus dou by dou y of j plus dou by dou z of k. That's the value of del. Now, let us go back and try to start with the left-hand side and arrive at the right-hand side of this particular result. So I'll start with del r power of n. So let me take del r power of n, LHS is del r power of n is equals to. Now del represents what? It is dou by dou x of I plus dou by dou y of j plus dou by dou z of k times of what? R power of n. Now we need to apply this partial derivatives on r power of n. But if I try to apply, I need to apply this partial derivative dou by dou x on r power of n, dou by dou y on r power of n, dou by dou z of r power of n. So 3 times we have to do this calculation. Rather, we can rewrite this to be equals to, it is summation of dou by dou x of apply on r power of n times of I. So whatever I'll try to differentiate, the same you can apply for y as well as for z. It is like a symmetric function, which means x will change to y, y will change to z, z will change to x. If you can just do it for x, I can change it x to y, y to z. Similarly, if I'm applying for y, if I'm applying for I, so I will become j, j will become k, k will be I, a symmetric function type. So therefore, I'll try to differentiate this partially with respect to x. So it is summation. Let us try to differentiate this r power of n with respect to x. So differentiation of r power of n will be n r power of n minus of 1. That is power differentiation. Into differentiation of r will be dou r by dou x. Into that I will remain as it is. Now I need to find out this value of dou r by dou x. So let us try to find out the value of dou r by dou x. From where? From this particular equation. So let me take this as equation number 1. So because there's square root over here, differentiating this square root will become a bit difficult. It is better to remove the square root value. So to remove the square root value, the best thing is square on both sides. So we'll square equation number 1. So we'll take this as equation number 2. So start with squaring equation number 1. Square equation number 1. So r will become r square and square root will cancel out. We'll just be left out with x square plus y square plus z square. So because you're having square root over here, the moment you remove a square, the square root will vanish and you'll just be left out with x square plus y square plus z square. So now since you have got this value, I'll try to differentiate this one partially, differentiate partially with respect to x, partially with respect to x. We try to differentiate. Derivative of this r square will be 2r into derivative of r with respect to x partially will be dou r by dou x. X square differentiation with respect to x will be 2x. X square differentiation is 2x plus y square. Because we are differentiating partially with respect to x, y and z are constant. Y and z are constant. So y square is a constant, so derivative will be 0. Z square is a constant, so derivative will be 0. So hence, we have got the value as 2r dou r by dou x is equals to 2 times of x. Now we can cancel out this 2 and 2. We are left out with r dou r by dou x is equals to x. I want only dou r by dou x. Dou r by dou x will be x. And this r you can cross multiply, it becomes divided by r. So this r we have cross multiplied and we got it as x by r. So dou r by dou x will be equals to x by r. Now this value we can substitute it back over here in equation number 2. So therefore, substitute this value in equation number 2. So LHS is equals to, we have summation of, it is n r power of n minus of 1 into dou r by dou x will be x by r into I. Can you see here? N r power of n minus 1, dou r by dou x have plugged in the value as x by r into I. Now let us further simplify this one. This is summation n r power of n minus of 1. Now this r which is in the denominator, it represents r power of 1. But if I take this r power of 1 in the numerator, it becomes r power of minus 1. So plus 1 power in the denominator will become minus power in the numerator into x into I. That is nothing but summation of n. If you try to observe, the base is r. So whenever the bases are the same, powers can be added. So bases are the same, you can just add the powers n minus 1 and this power is minus 1 into x into I is equals to summation of n r power of n minus 1 will be how much? Minus 2 times of x into I. Or further, if you try to simplify this one, so I'll take this n outside the summation r power of n minus 2 outside the summation and write down summation of x into I. Or it is n r power of n minus of 2. If I remove the summation, then in that case, I have x and I, so I have to use this symmetric property, change x to y, y to z, I to j, j to k, k to I. So I'll start with xi. The first value I'll write xi only, xi plus. Now x will become what? X will shift to y and I will become what? I will become j plus y will become what? Y will become z. It is x, y, z. So I, j will become k. That is nothing but n r power of n minus of 2. And what is this xi plus yj plus zk? It's already given in the question as vector r, right? So it is given in the question over here as vector r. So let us try to replace that by vector r. So we have got this as vector r. Now, is this nothing but your RHS? N r power of n minus 2 into vector r. So we started with this particular result over here. Del r power of n is equals to, now we have got it as n r power of n minus 2 into vector r, which is the required solution. I hope you understood. If you have any questions, any queries, you can just put in the comment box. That's all I have for today. Thank you.